Welcome back. Today in Chapter 7, we're going to focus on telecommunications, the internet, and wireless technology. Here we look at the recent developments in overall networking technologies. Can you think about an example of convergence? How fast would you say that today broadband is? Note that in 2000, typical internet access speeds were about 56 kilobits per second over a telephone line, costing 25 cents per kilobit. Whereas today, broadband speeds are anywhere from 10 to 50 megabits per second and costing 1 cent per kilobit. Think about your internet connection, whether it be at home, at school, maybe at work. Do you know how fast it is? Do you know what your speed is on your cell phone internet connection? Point here overall is to try and raise awareness of telecommunication systems. When we look at and attempt to understand what a network is, we look at the components that ultimately you'll find in a simple network, which we will clearly see on the next slide. Can you think about a overall function or describe the function of a NIC or NIC? What about a connection medium? Do you understand, or could you describe the purpose of a hub or a switch or a router? Even if you're not a techie, many of you probably worked with or are familiar with these types of things just from setting up your own home internet systems. Illustrated here is a simple computer network consisting of computers, a network operating system or NOS, residing on a dedicated server computer via cable wiring connecting the devices, switches, and a router. Although the NOS is shown as part of the server, note that depending on the type of software, an NOS may also be designated to reside on client computers, which also are called peer-to-peer networks. Do you have a home computer network? Could you describe the elements of that network? When thinking about the network of a large company, this slide looks at the additional components that one might expect to find, particularly when there are many locations, thousands of employees. What is meant by the back-end system? Note that many firms are dispensing with traditional landline telephone networks and using internet telephones that run on existing internal data networks and the internet. Today's corporate network infrastructure is a collection of many networks from the public switched telephone network to the internet, to corporate local area networks linking workgroups, departments, or office floors. Here we illustrate the components of a large company's network. Note the difference between the wireless LAN, which allows wireless access within the office, and the mobile Wi-Fi network, which allows internet access to employees outside of offices. The advantage of telephone-based wireless systems is that they do not require a Wi-Fi hotspot to work, and in fact, can connect users to the entire globe through their telephone networks. Cable networks, major competitors of telephone company internet providers, have recently developed a mobile option. Optimum Cable, with Comcast, has installed neighborhood Wi-Fi spots, allowing cable subscribers wireless access to the internet. This slide and the following couple look at the main technologies in use today for networks: client-server computing, packet switching, and TCP/IP. Here we look at the second, packet switching. Note that circuit switched networks previously were expensive and wasted available communications capacity. The circuit had to be maintained whether data was being sent or not. It's also important to note that packet switching enables packets to follow many different paths. What is the advantage of this capability? If one path is blocked due to an accident or power failure, the data will automatically be shifted by routers to open paths. However, in truly massive outages like September 11th, nearby metropolitan servers were even knocked out, and for a period of several days, internet access was limited in the New York metropolitan area. The notion that packet switching networks would survive a nuclear attack, obviously highly unlikely. Data are grouped into small packets, which are transmitted independently over various communication channels and reassembled at their final destination. This graphic illustrates how packet switching works, showing a message being split into 3 packets, sent along different routes, then reassembled at the destination. Note that each packet contains a packet number, message number, and destination. This slide continues the discussion of the 3 main networking technologies in use today and looks at TCP/IP. Note that in a network, there are typically many different types of hardware and software components that need to work together to transmit and receive information. Different components in a network communicate with one another only by adhering to a common set of rules called protocols. In the past, many diverse proprietary and incompatible protocols often force business firms to purchase computing and communications equipment from a single vendor. But today, corporate networks are increasingly using a single, common, worldwide standard called Transmission Control Protocol/Internet Protocol, or TCP/IP. TCP/IP actually is a suite of protocols, the main ones of which are TCP and IP. This figure illustrates the 4 layers of the TCP/IP reference model for communications. Note that what happens when computer A sends a message to computer B is that the data that computer A creates is transferred within that computer from the application layer to subsequent layers in sequence. In this process, it is split into packets and information is added at each stage, ultimately translating the packets into a form that can be transferred over the network interface. After traveling over the network interface, the packets are reassembled at the recipient computer from the network interface layer up, ultimately for use by the application layer. This slide looks at the types of networks that organizations use. Do you know what the differences are between digital and analog signals? Can you describe and distinguish between LANs, CANs, WANs, and MANs? Note that a network can be defined by the way that clients interact, the type of physical medium to carry signals, and the way in which computers are connected and send signals to each other. A modem is a device that translates digital signals into analog form and vice versa. so that computers can transmit data over analog networks such as telephone and cable networks. This graphic illustrates the differences between digital and analog signals and shows how digital signals can be sent to other computers over analog cables such as telephone and cable lines, which are analog. Note that digital signals are representations of the two binary digits 0 and 1 and are represented logically as on and off electric pulses. Here we look at the media involved in network transmission. Note that many of the telephone systems in buildings had twisted wires installed for analog communication, but they can be used for digital communication as well. Today, telecommunication companies are starting to bring fiber optic cable into the home for high-speed internet access. Note that the transmission capacity of a medium, or bits per second, is dependent on the frequency, which is measured in hertz, or cycles per second. Here we examine what the internet is. The text refers to the internet as the most extensive public communication system and the world's largest implementation of client-server computing. Do you know what an IP address is used for? Why do we have a domain name system? And why don't we just use IP addresses? The domain name system makes it possible for people to remember addresses. How do you connect to the internet? Does anyone use a satellite? Note that T-lines are leased, dedicated lines suitable for businesses or government agencies requiring high-speed, guaranteed service levels. The domain name system is a hierarchical system with a root domain, top-level domains, second-level domains, and host computers at the third level. This graphic describes how the domain name system works. Note that the root domain is the period that is used before the top-level domain, such as .edu or .com. The diagram depicts the domain name system. In the diagram, the internet root domain is the highest level of the name system. The top level domains include edu, com, gov, org, net, and other domains. Second level domains for .com include Expedia and Google. A second level domain for .gov is Congress. A third level domain would include hosts. For example, sales would be a host at Google named sales.google.com. The host computer, computer 1, at this level would be reached at computer1.sales.google.com. The internet has many governmental, international, and professional bodies that govern its policies. In addition, many countries have created partially independent domestic internets that are controlled by government intelligence agencies. The concept of a global internet is no longer a reality. For instance, internet users' experience in China or Iran is different from the internet experienced in the United States, EU, and other Asian countries. The internet backbone connects to regional networks, which in turn provide access to internet service providers, large firms, and government institutions. Network access points, or NAPs, and metropolitan area exchanges, MAEs, are hubs where the backbone intersects regional and local networks and where backbone owners connect with one another. This graphic illustrates the architecture of the internet. Note that MAEs are hubs where the backbone intersects regional and local networks and where backbone networks connect with one another. The internet is over 50 years old and approaching the limits of early design decisions. IPv6 will provide trillions of new addresses, and higher speed networks will provide additional transmission capacity. Here we continue about what the internet is, looking at the services or applications that the internet supports. Note that the internet comprises many more services than just email and the web. Which of these services, beyond email and the web, have you used? And if you have, would you be able to describe how it works? Client computers running web browsers and other software can access an array of services on servers over the internet. These services may all run on a single server or on multiple specialized servers. This graphic looks at the services that an internet server computer can offer. Websites, HTTP, email, SMTP, file transfer, FTP, newsgroups, NNTP. It illustrates where on the path between client and back-end systems these services lie. Anyone who has cable internet telephones are using what's called voice over IP or VoIP. Other popular technologies that use the internet as a platform are VoIP, unified communications, and virtual private networks. A VoIP phone call digitizes and breaks up a voice message into data packets that may travel along different routes before being reassembled at the final destination. A processor nearest the call's destination, called a gateway, arranges the packets in the proper order, directs them to the telephone number of the receiver or the IP address of the receiving computer. Here we see how voice over IP works. The voice messages are digitized and transported over the internet in the same packet switching method as traditional internet data. Gateways are simply computers or network devices that maintain the interface with the internet in a firm. The VPN is a private network of computers linked using a secure tunnel connection over the internet. It protects data transmitted over the public internet by encoding the data and wrapping them within the internet protocol. By adding a wrapper around a network message to hide its content, organizations can create a private connection that travels through the public internet. Here, we look at one of the most popular services on the internet, the web, and the main protocols enabling it. The web is an interlinked connection of websites, which are collections of web pages linked to a home page. These pages are created using a text markup language called HTML and is transmitted to a user's web browser by HTTP. Web page addresses, or URLs, are composed of the domain name of the website and the file location of the individual web page. Have you created a web page using HTML? Here we look at how people find information of interest on the web. Primary method, as we know, search engines, which today act as major portals to the web. Most users will be Google users. Have you ever looked at Bing, the Microsoft search engine that is now showing some promise? This graphic ranks the major search engines according to popularity or percentage of total number of searches performed, Google being a clear favorite. The Google search engine is continuously crawling the web, indexing the content of each page, calculating its popularity, and storing the pages so that it can respond quickly to user requests to see a page. The entire process takes about half a second. This slide focuses on some of the possibilities for sharing information on the web. The Internet of Things includes the idea that our cars, refrigerators, heaters, air conditioning units, along with all other appliances and buildings, eventually will be on the internet. We're making slow progression there today. We'll continue to see how far we move. Here we discuss the continuing revolution in wireless communication. What changes or improvements have happened in your cell phone service over the past 2 years? Have you purchased or upgraded a cell phone in that time? If so, why? Some cell phone users today still rely on 3G networks, a standard which first appeared in the early 2000s and was improved upon over the last decade. 3G networks have mobile upload capacities of about 144 megabits per second, enough for email and some web browsing, but not videos. "4G networks started appearing in 2010 in the US. They are also called LTE, or long-term evolution networks. 4G cell networks can be used for display of video on mobile devices with download speeds of about 100 millibits per second and upload speeds of about 50. 5G is the newest standard, and now we see some progression towards a 6G. Have you ever used Bluetooth or wireless devices for computing, such as keyboards, earphones, or other? Note that in most Wi-Fi communications, wireless devices, communicate with a wired LAN using an access point. Have you ever connected to the internet through a hotspot at the airport, coffee shop, hotel, or other location? Can you think of any security issues of using smartphones to access the internet at, say, Starbucks? Bluetooth enables a variety of devices, including cell phones, smartphones, wireless keyboards and mice, PCs, and printers, to interact wirelessly with each other within a small 30-foot, 10-meter area. In addition to the links shown, Bluetooth can be used to network similar devices to send data from one PC to another, for example. This graphic illustrates an 802.11 wireless LAN operating in infrastructure mode that connects a small number of mobile devices to a larger wired LAN. Most wireless devices are client machines. The servers that the mobile client stations need to use are on the wired LAN. The access point controls the wireless stations and acts as a bridge between the main wired LAN and the wireless LAN. A bridge connects two LANs based on different technologies, like your wireless network to your Blu-ray player, so that you can download internet movies from Netflix and watch them on your TV. This is one of two wireless technologies that is having a major impact on businesses: radio frequency ID. Can you think of examples where RFID is used today? Most notably, Walmart uses RFID technology to manage inventory and supply chains. RFID uses low-powered radio transmitters to read data stored in a tag at distances ranging from 1 inch to 100 feet. The reader captures the data from the tag, sends them over a network to a host computer for processing. The graphic illustrates how RFID works. Here we look at a second wireless technology having another major impact on business: wireless sensor networks. The small circles represent lower level nodes, and the larger circles represent high-end nodes. Lower level nodes forward data to each other or to higher level nodes, which then transmit data more rapidly and speed up network performance. Next, we will focus on Chapter 8.